What about now?
There we go. I think I can see everything there. Perfect. Yeah, I can see the slides now. Thank you.
I'll go into the slideshow mode. You tell me if you see it.
Awesome. There we go. Good to go. Thanks, Yassine.
Cool. Yeah. So I was saying that when I started to write infrastructure as code, I had that feeling. So I don't have the same flows, processes, and also tools that helps me to accelerate my coding turnaround time. And I was wondering why we have that gap between app and infra code, knowing that the value resides in application code as well as in infrastructure code. And I was even wondering if there's any way to bridge that gap. And this is definitely one way to bridge that gap. And what I suggest today is whatever we learned from our DevOps journey, from our DevOps approach, mentality, and culture could be applied to infra code. So when you write a piece of code using Terraform, for instance, this is just the beginning of your journey. And we should build an ecosystem around the said Terraform code. That ecosystem resides and relies on different pillars. The first one is CI/CD, a CI/CD flow that goes beyond the classic Terraform init, plan, and apply. A better developer experience so your developer can innovate and iterate and deploy with confidence in production. Security and governance. And this is in line with the shift left paradigm. So whatever we do in production in order to pen test the infrastructure or detect any security misconfiguration could be done when we write the Terraform code. And last but not least, the fourth pillar, operations. And by operations, I mean two things. Day two operations, but specifically provisioning. And this is what Andrew tackled in his talk, how we can write a set of Terraform code that is easier to share and easier to reuse afterward. And this leads me to talk about the collaboration model. Before even we write a single line of code, we need to know what our team size, our capabilities, the team's responsibilities. Do we have a dedicated platform teams, or we are just a bunch of individuals who knows how to write Terraform code and we do our best? The provisioning model that we want to have within our organization, is it pipeline driven, TFC driven, or we have the luxury to code a nice and fancy UI for self-serve? But there's one flow that really works. That flow, if you used any modules from the public Terraform public registry, you used it, the producer and the consumer. With Andrew, we've seen how to use that, the second flow, the consumer, basically to roll out features that deploys resources in the cloud. For the first one is the flow about the producers, the guys who writes actual modules. And then with a pipeline of some sort, the outcome is a versioned module over here. We will see in the next slide how we can implement a pipeline with the outcome, a module that is tested, secure, battle hardened, and obviously versioned, so we can share it and standardize the purpose of that module across your organization. This is one example of this flow, and by no means the example. As you can see, it's pipeline driven, PR driven even, and we can notice two flows: the developer flow from the left-hand side and the module flow on the right-hand side. So we see a classic approach. If you worked in the software space, the developer writes some code, you will have some pre-commit hooks that does some sanity checks on all the file that it's being committed, so you don't push garbage to your VCS. Whenever you do that and you raise a merge request, there will be a pipeline associated to your merge requests to make sure that at least you have some sort of smoke tests being executed against your PR. And then you have the reviewers, review your code, push some comments, suggest some comments, and then that loop goes on and on, until everybody's satisfied with your change or you get fired. So once that PR is getting approved, the code is being merged, and this is where the module pipeline on the right-hand side kicks itself with the purpose to execute some steps. We will see them in a minute. Execute some steps, and the outcome will be a published module with a version attached to it. And this is what I suggest as building blocks. And I really meant to call this slide building blocks to not have the exhaustive list of tools that does different steps that you see in here. And I don't want to have a debate around which tool is better than what. So again, in the pre-commit side, the left-hand side, you will see what you can do. For example, Terraform validate, the native command, Terraform FMT in a recursive manner. You can use tflint to do some linting with some provider deprecation. It can detect that as well. There's also Terraform doc that generates your documentation automatically for you, either if you run it as a standalone command or if you make it as part of your pre-commit hooks as well. The next step, linting validation. This is more for the aesthetic part of the things. So Terraform validate, Terraform FMT. If you have any commit standard, should be part of it as well. The security scan step. This is what we talked about earlier. This is about to shift left all the security scanning that you do in a passive way. This is static security scanning. So with the tools that I list here, Checkov, TFSec, TerraScan, we have the ability to scan in a passive way all your HCL files and detect if there's any security misconfiguration. An obvious one will be if your organization doesn't allow public S3 buckets, you can have it detected and flagged by one of those tools. The tests, and this is one of my favorite topics, and I guess Jenna talked about it at length. Here, this step will tell you how serious are you about infrastructure as code. So either you have some smoke test, integration tests, unit tests, or end-to-end test with respect to the pyramid of testing, obviously. What I suggest here, two known tools, TerraTest and Kitchen Terraform. And hopefully at some point we will have a native Terraform testing framework at some point. And the last step, this is the CD part of CI/CD. Say that we passed all those steps. The idea here is to tag that code with a semantic versioning schema, measure, minor, patch, release. And you can do it either manually if you want, or you can automate that process. Semantic release appears to be one of the tools, at least my favorite, put it this way, that takes as an input the commit message and decide if it's a measure, minor, or patch release. And of course, you need to follow a commit message standard. The one that semantic release depends on is the Angular one. And then as a bonus, if you are a TFC user, you can configure your VCS to push a new version into your private module registry in TFC automatically. So whenever there's a new get tag, TFC with the integration in place will detect a new get tag and push or pull that version into PMR in order to have a new version. And this is what we will see in this demo. I will try to skim through, running out of time. So in here, the purpose is to have a module for S3 in AWS. We will see the pre-commit hooks that I have in place in my laptop, the execution of them, the tests as well, opening a PR, the pipeline associated to the PR. Once that PR gets approved, or before even the approval, you will see that the pipeline associated to my PR. So Checkov for static code analysis, TerraTest for testing, then the approval of the PR and merging the code. And this is where the module pipeline will kick itself. And the extra step that you see in here is the release. So we'll, based on the git commit, that tool, semantic release, will decide if it's a measure, minor, or patch version. create the get tags and push that get tags into my VCS, and afterward you will see that I have a new version pushed into my own TFC PMR registry. So without any further ado, I'll try to speed things up. I've noticed that some of my colleagues recorded the demo. This is a nice idea. Maybe on the next talk, this is what I will do. So first thing first, testing. So as I mentioned, I love Terra test. Maybe at some point we will use Terraform in a native way to create tests. The purpose of this module is to create an S3 bucket. So this is my code, really simple one. It creates an S3 buckets in my AWS account. And in here, I have a fixture that mimics calling that module with some specific inputs. And what I do in my test, briefly, pointing my test to my fixture code, I have the ability to put some options. Here, I'm destroying all what I instantiate at the end of my test, thanks to the defer function.
It
The
looks like
init and upper.
Yassine that we lost a video on that again. So sorry.
Okay, that's strange. Okay, I'll stop sharing and reshare again. Apologize for that.
No worries. Wouldn't be a live event if we didn't have a few bits and bobs go the wrong way.
Okay. Tell me if you guys see my screen.
All right, that looks good now. Yeah, I can see your code now. Thank you.
Okay. Yeah. So this is my Go test. Again, apologize for that. I do a Terraform destroy at the end of my test just to always start from a clean state. Terraform init and apply to deploy whatever I have in my fixture. And at the end, what I do, based on the output, I make sure that I have the right ARN with the right S3 bucket ID. So if I go execute that, this is exactly what this code will do if everything works fine. There you go. And you see exactly what this test is doing, thanks to the logs that we have over here. So at the end of the test, everything will get destroyed. So the tests are independent in nature, and you can compile and compose any test scenario that you want. This is really the basic one, but you can have test setup and test tear down afterward to set up some inputs or some specific scenario for your module. As you can see, the test passed. So the next thing that I want to show you is the commit hooks that I have. So this is my S3 bucket code. I'll go ahead and just disable versioning in my S3 bucket. And if I try to commit this file, Chekhov doing the static code analysis will scream and won't let me commit that file. So get that. Okay. Of course, this is a live demo. So I'm trying to commit. See if I can move this one. Yeah, I'm trying to commit, and I have some pre-hooks installed on my repository. And as you can see, it screams saying, I won't let you commit because you have some security checks that is not being respected. And the one in question is this one. Check AWS 21, ensure all data stored in S3 buckets have versioning enabled. I can even have another scenario where I will introduce some really ugly formatting over here, running the same thing. Now, Terraform FMT will say your file is not formatted correctly, which is really helpful before you commit everything to your VCS and just waste your pipeline resources. You can do that locally and you have a faster feedback loop. Now that everything is in place, the next thing that I want to talk about is the pipeline itself, or the pipeline definition. As you can see, there's no pipeline code. This is for GitLab, by the way, I should mention it. All the pipeline definition resides in a template. So with that, you alleviate that burden from your developers, and they don't need to care about how the pipeline is being constructed or even know the details behind it. And you can bake in that definition or those two lines in the project template. So whenever you have a new module, you instantiate your project template and you have already a skeleton of how it should be your pipeline, and you are ready and good to go. So assuming that I open a PR, I'll introduce just a fake thing. Of course, I didn't fix what I had previously, and this is good. And you see the execution live. So I've talked about semantic release, and this is the standard that you need to respect in your commits message. If you want to enforce it, if you don't want to learn it by heart, as I do, you can have a tool called commit citizen or commit lint, just to make sure that you respect that standard and you have an interactive way to have your commit strings the proper way. Say test 1, 2, 3. If I push, I should be able now to open up a merge request in my GitLab. There you go. So I will open up quickly that merge request, and you see that there's a pipeline associated to my merge request or pull requests. There you go. You see that pipeline, and inside that pipeline, you see that I'm doing several steps over here. So security static analysis and a test to execute the test that I did previously manually in my laptop. So I'm not going to wait for this one to be executed, but I'll show you a previous execution. So I won't consume more time. And you see here the two types that I was talking about, the merge request or the pull request pipeline and the master pipeline. So whenever we do a code merge, there's another pipeline that is being executed. If you go inside, you will see the steps: security static analysis, test, release. And from the list that I shared with you guys, you can compose any pipelines that suits your need with the proper steps and alignment of the steps as well. So this one is a nominal scenario that succeeded from A to Z. And at the end, I have that release step that takes my commit message, as you can see in this line over here, analyzing commit, this commit, and it decides that with this commit, the next version will be 2.4. Previously, it pulls the previous tags and decide that the next one, since this is a minor one, is going to be 2.4. And automatically over here in my project, I can see the list of tags that I had before. So 2.4 is being pushed into my VCS, and the assumption is my 2.4 should be here. So this is TFC, and this is my private registry. My super S3 module is here, and I have not only the documentation baked in, but as well all the input and output. A link to my code source as well. And my 2.4 is not here, but you can see the previous one that I pushed prior to this talk, 2.3. So what we have seen so far is the ability to push secure, reliable, and battle tested modules. So later on, you can compose your solution to spin up a piece of infrastructure using a self-serve kind of mechanism, or even using another pipeline, as my colleague showed before. And this concludes my talk. What I want to send you guys as a message is your infra code is as important as your app code. Automate your workflow to catch bugs and problems early. Otherwise, it's going to get expensive and somebody will need to debug problems at 3 a.m. in the morning. Invest in your team's tooling and workflow to give them a better developer experience so they can iterate, innovate quickly, and deploy with confidence in production, perfect every time. And thank you. So I'll take questions in the chat, and I'll share probably the code source as well later on in the day.
Great. Thank you so much for that talk. I love the focus on treating infrastructure code as seriously and with as much care as application code. So thanks for speaking with us today. It was